Delaware Tech, Chemistry 100, Chemistry 110, Heterogeneous Mixtures, Colloids, and Suspensions. So we've already talked about solutions. Solutions are homogeneous mixtures. They have one phase, and the particles are very, very small that are dissolved in the solution, so they stay in solution by interaction with the solvent. Solutions will appear transparent. They may have a color. Most solutions do not, but light will go through them quite easily, and you can pretty much read through the solutions. So examples of a solution are things you already know about. Sugars dissolved in water like glucose, or salts dissolved in water like saline solution. But we also have something called dispersions. Dispersions are heterogeneous mixtures. They're not completely mixed molecule by molecule the way solutions are. And given enough time, they may even separate into two or more phases or layers. So they come in two varieties. The first one is called a colloid, or colloid suspensions, colloid dispersions, or colloid solutions, but really they should be colloids or colloidals. And these are medium-sized particles mixed with a solvent. And they tend to stay mixed because of random motion, what's called Brownian motion, named after a scientist whose name is Brown, of the relatively small particles. They're bouncing off of each other, and they may be even repelled by each other due to similar charges. So negative charges will bounce off of negative charged particles because they have the like charges, and they will repel one another. And if you have enough of this random motion, the particles will stay mixed, but they're not a true solution. And the other variety is called a suspension. And suspensions are more obviously a heterogeneous mixture because these are large particles that only stay mixed because of mechanical mixing or shaking. In fact, the second that you stop mixing, they stop staying mixed. So let's look at colloids or colloidal mixtures. They appear translucent, so light goes through them only a little bit. And they're somewhere intermediate between a solution and a suspension in their behavior. So examples of a colloid would be emulsions like milk or mayonnaise. These are mixtures that have microscopic particles, molecular-sized particles, but they're fairly good-sized molecular particles that stay mixed over long periods of time, but if you give them enough time, they'll start to separate. Now, suspensions, these are much larger particles, and they'll separate almost immediately after you stop mixing them. So they appear cloudy or completely opaque, and suspensions would include things like a fine sand water slurry. So if you mixed sand and water and you kept shaking the mixture, they would stay together, but the second you stop mixing, they'll separate. And muds are also considered suspensions. So let's look at some examples of colloids. And there are many, many examples of colloids that you see in everyday life, and a number of them are actually foods. So we have what's called the dispersed phase and the dispersing medium. So one will help mix the other. So the medium will mix the dispersed phase. And they can be mixtures of solids, liquids, and gases, just like solutions. And these can include things like soap suds, whipped cream, even rocks like pumice, which are very light stones because there's so much air inside the pumice stone. In fact, pumice stones are so light in density that they will actually float on water. Marshmallows, mists, and fogs and clouds are actually liquid aerosols. So aerosols are a type of colloid. A lot of foods, cream, mayonnaise, milk, butter, cheese, these are all emulsions that are made from liquids with liquids or liquids from solids. Smoke is something that you think of as a gas, but in fact it's really a mixture of microscopic particles or particulates floating around in the gas. So smog is another example. Aerogels, these incredibly light gels that are made with gases infused into solids. Starch when you dissolve it in water, it doesn't actually dissolve completely. It makes kind of a slurry, what's called a colloidal dispersion. And there are even solids in solid colloidal systems like pearls or opals. These are opals are minerals that are considered semi-precious stones, as are pearls for that matter. Alloys. Most alloys are actually solutions because they're completely homogeneous mixes of a metal with either another metal or a non-metal. And most of the alloys you know by name are actually solutions. So steel and brass and bronze are actually solutions because atom for atom, they're very well mixed. But there are other alloys that if you looked at them under the microscope, they are not completely mixed. You'll see a particle of one metal and a particle of another metal, and they won't be just atoms, they'll be larger groupings, so these would be considered a solid sol, a colloidal system of solids. There's an effect that we see among colloids and some suspensions called the Tyndall scattering effect. And this is an effect where when light passes through the mixture, the light waves are bounced off of the microscopic particles that are in colloids. But in solutions are so well mixed, they're so homogeneous that this scattering doesn't occur. So you can easily see the scattering if you took in this case, we're shining a very specific wavelength of light, but you could actually do this with a flashlight on some colloidals, shine it, and you'll see the colloidals will capture the light, they'll actually refract the light, and you can actually see it as a band where the light is going through in this colloidal, but you'll notice you don't see it in the suspension. And that's called Tyndall effect. Suspensions, as I mentioned, are mixtures that will separate as soon as you stop mixing them. So here's an example of calcium carbonate, which is not very soluble in water, and somebody mixed it up, and you can already see that layer forming at the bottom because once you stop mixing, they'll just settle into two layers, the water separating from the calcium carbonate very quickly. Okay, so let's look at a comparison between solutions, colloids, and suspensions. There are a number of differences between these. Remember, colloids are somewhat intermediate between the properties of solution and suspension. But let's look at the different properties. First of all, the solute particle, and solute may not be exactly the correct term for these heterogeneous dispersions, but we'll call it the solute particle. So those particles tend to be very small in solution. They're completely dissolved. Every single solute particle is completely surrounded by the solvent in favorable interactions that hold the solution together. Sometimes you'll get much larger particles, but for the most part, they'll be fairly small. In colloids, however, now you have intermediate-sized particles. These are considerably larger than what you typically find in solution, and the reason for that is they are frequently molecules or collections of molecules in aggregates that are actually aggregated with other molecules, frequently making layers of particles. So the particles will have layers to them and be very large, and they'll be floating around in the solvent, but in a fairly stable fashion. But by the time you get to the size of particles found in suspensions, these are very, very large particles, and the second you stop mixing, of course, they'll settle out. In terms of homogeneous mixtures, the homogeneity of a solution, it is homogeneous. It's clear or occasionally colored. It's transparent, meaning the light will go through it. You can read through it very easily, and these are very easy to spot. Colloids are a little harder to spot. They tend to be cloudy. The cloudiness is much easier visualized when you shine light through it. They are technically heterogeneous. And they are translucent, so some light may go through them, but not a lot. Whereas by the time you get to suspensions, they're very cloudy and they're heterogeneous, and frequently no light will go through them at all. They're opaque in many cases, and you can even see multiple substances floating around in the solvent as far as the whole mixture goes. In terms of filterability, you can only filter a suspension. The other two the other two, solutions and colloids, all of what's in there will go right through the filter together, unless you have incredibly tiny molecular filters that are separating atom by atom. But your typical filter that you might use in a laboratory will not separate solutions or colloids, but they will easily separate suspensions. Think about a mixture of sand and water. That will be separated by a filter, but if you had salt dissolved in water, well, the salt water will just go through your filter. In terms of settling, the solutions will never settle. They'll stay in solution indefinitely unless you suddenly put them in different conditions, like you chilled them down or you put them under different pressures. But in general, solutions will stay in solution for long periods of time. Colloids will also stay in solution, stay mixed for long periods of time, though eventually you will see some settling. In case of suspension, the second you stop mixing, they'll begin to settle out. So it says here eventually, but most will settle almost immediately. And the Tyndall effect is this light refraction or reflection off of the particles that are in the mixture floating around. In the case of solution, the particles are so small that no light bounces off of these particles and will just pass right through the solution, so there's no Tyndall effect. Whereas in colloids and some suspensions, the particles are big enough that they will refract the light that goes through the liquid. And you can actually see this. In some suspensions, they're so opaque that light won't go through it, so there is no visible Tyndall effect anyway. And with that, we'll stop here.